4 years ago, the first controller with anti-stick drift Hall Effect Thumbsticks appeared on the market, and it had the shittest name on planet Earth. Since that release, the complexity of thumbsticks has gotten out of hand, so today we're focusing on how technologies like Hall Effect and TMR apply to controllers and help the aim assist gamer gimps enjoy their joysticks for longer. We're covering normal sticks and how they drift, how TMR and Hall Effect counter one major aspect of that drift. We're doing some testing featuring 2 controllers with each type of stick. I have also done teardowns for each type of stick. I'll be going over my overall favorite thumbstick design. I am doing all of it and everything I can with sticks today, except for capacitive sticks, which will be covered in a separate project in the future. We are focusing on magnet sticks today. But before we get into this, you thought there was a sponsor. No, what I was going to say is it took almost half a decade to get to this video. I was originally going to do it back in 2021 or 2022 and have been terrified because thumbsticks are still, to this day, kind of a mystery. It's not nearly as straightforward as something like a keyboard. It's more so like the universe. You never know what the fuck is going on, but it's really fun trying to figure it out. To help us understand a lot of what's going on, I'm going to be referring to the research, website, and testing device created by John Punch, as well as the research done by others like Marius Heyer and myself. Links to everything will be in the description, except the link to my research. That link is above the description. So, where does our problem begin? Marius once described to me, in simple terms, 3 attributes that help us understand a joystick: the mechanical structure, the sensors used, and how the data from those sensors is broken down and sent back to the host device like a console or PC, and I fully agree with this explanation. Stick drift is, for the most part, a result of the current standardized thumbstick design. They use carbon film potentiometers, which we're going to call POTS for the rest of this video. Cue the how it's made music. The mechanical structure is designed to move on 2 axes. This piece pivots this direction while this piece pivots in the opposite direction. Connected to these axes is a piece of plastic with a little metal wiper on it. And connected to the external stick box is the potentiometer. The pot has a thin carbon track, and when the stick is moved, it moves this wiper, which then rubs across the surface of this carbon track, giving us a measurable change in voltage, but only on one axis. Think of it like a clock face that outputs in one direction, left or right. But if you put 2 of these potentiometers together, now you have left, right, up, or down for a full range of motion. Now, how do pots get drift? This carbon track is complete dog shit and wears down over time, which causes huge interruptions in the signal. Aside from unsoldering the stick or the pots themselves and replacing them, you are shit out of luck. The other 2 methods for drift to worm its way into your life are through the recentering spring, which loses tension over time. This causes sloppy movements at the center, but our last form of stick drift does the same, and it's something I've never really talked about before, but it is stretching. Like the spring, the plastic components also experience wear and tear over time. The mechanical structure is encased in metal, but it is usually just thin, greased up plastic. While we will be covering tension here in a second, we have 3 solutions for stick drift stemming from pot drift. That would be the Hall Effect, TMR, and capacitive joysticks, and we are going to start with Hall Effect. From my current understanding, the Hall effect is when a material allows an electric current to pass through it, and that electric current is changed by a magnetic field. This is the basis for how the Hall effect fights stick drift, and as you can see by my retarded explanation, this whole process happens with no contact, while the other process with potentiometers happens with full contact that wears down the sensor. That shit is lame, so how do we apply the magical technology to thumbsticks? With full-size Hall effect sticks, meaning Hall effect sticks that look a lot like average Alps potentiometer thumbsticks, the Hall effect sensor is stationary and embedded in the same place the carbon track would be for a potentiometer stick. Connected to the mechanical structure is obviously going to be the wiper, which in this case is going to be a magnet. These magnets rotate next to the Hall effect sensor, causing that change in voltage and giving us our output. We'll cover mini sticks and the Flightity thumbsticks here in a second, since those are designed a bit differently. But first we have to move forward with TMR sticks. What the fuck is a tunnel magnetoresistance? TMR is similar to Hall effect, but functions via quantum mechanics. Don't know anything about that dumb shit. But essentially, while Hall effect and TMR are both based in magnets, TMR sensors offer higher sensitivity and lower power consumption, which leads to better thermals and better overall performance at the expense of a higher price. And thermal performance is more important than one would think. John Punch noted in his research that during response time tests, Hall Effect sticks have degraded performance at the end of the test because of thermals, whereas capacitive joysticks do not have this same issue. Which means there's a whole hell of a lot to look into for that video. But we're doing magnet we're doing magnet sticks today. This is a magnetic tunnel junction, which is two ferromagnetic layers separated by a thin insulating. What in the fuck am I doing? I am talking to the general gaming audience. Anyways, this top layer is free, the bottom layer is fixed, and the top layer is obviously going to be manipulated by the movement of external magnets. The magnets get moved around by the mechanical structures, so you move your stick, the magnets move, they move that layer around, and bing bang boom, now you're ruining some guy's night after he's gotten home after his 9 to 5. In short, TMR is kinda like the natural evolution from Hall Effect sticks. And please feel free to write a comment if you have more information or would like more information regarding either of these topics. There are a lot of nerds out there who know more than I. The first thing you'll notice on Hall Effect or TMR sticks is less resistance from the less resistance because there's no potentiometers resisting your movements. But there's also the very important fact that many of these Hall Effect and TMR sticks have used weaker recentering springs. Both of these factors lead many to hate these sticks, and in some cases, when done very poorly, Hall Effect and TMR sticks can have poor recentering because, again, there's no friction from the sensor itself. Some Hall Effect and TMR controllers have tension comparable to stock controllers, which the DualSense sits at 60 grams and the Series X controller sits at 50 grams according to my measurements, but many Hall Effect and TMR controllers hit 35 or less, and people simply aren't used to that. More importantly, springs lose tension over time, so starting off with a limited amount of it does not seem ideal. But a lot of this comes down to design, and speaking of designs, there have been many attempted for Hall Effect and TMR sticks so far. They usually have something to do with shoving the sensors in some unique place, usually up your ass. Not yours, just up the ass of the controller. The one we already looked at is the tried and true Alps-inspired design that has the Hall Effect sensors and the magnet stuffed into this outer little casing on the exterior of the metal box. This means the stick needs power and usually receives this power by being soldered to the main board. Then there's the mini stick design, which is the current primary design for both Hall Effect and TMR sticks today. These have the sensors placed in the base of the sticks, so the design is quite clearly going to be a little bit different and affect your aim a lot differently. The mechanical structure itself is a lot smaller than other thumbsticks, and because the sticks are so small, the recentering springs are small, so they're very low tension. This stick right here, this stick is the sole purpose so many people hate Hall Effect and TMR sticks. I've heard descriptions like light, cloudy, fluffy, disconnected, but I don't mean to paint these in a really bad light. When done well, those sticks feel absolutely spectacular. However, then we have something like the FlyDigi Vader controllers, which don't even have the Hall Effect sensor attached to the thumbstick module itself. It's soldered to the fucking main PCB. This means the stick module itself only needs to consist of the magnets and the mechanical structure responsible for moving those magnets around the Hall Effect sensor. There are only 5 little tiny screws separating you from replacing the thumbstick on the Vader 5 Pro or Vader 5S, even the Vader 4 Pro. No soldering, no expertise needed. Replacements and repairs made very easy. However, designing a stick like this is highly complicated, and they have fucked it up a couple of times. Why is it complicated? Because the Hall Effect sensor is in the wrong goddamn place. But positioning the sensors in a better place would require the stick to have power. It wouldn't be repairable or replaceable moving forward. Look at this tension mechanism. It is external and also adjustable. As you can see, the tension spring is outside of the stick, but transfers this tension to the stick via a lever, which is why the first iteration, I believe, were called lever action sticks, if I'm not mistaken. I think they're called force flex sticks now. Some iterations have had recentering issues. The ones on the Apex 4 literally exploded. But overall, the modern iterations of these sticks are very interesting, and in my opinion, it's the most interesting stick out there for the future. We definitely need more drugs in R&D departments. I think that's a necessity. Before Razer became like an actual real company and started putting out garbage, they used to have people doing drugs in the back room who were designing this shit. I miss those days. Unfortunately, this stick still has a spring. The spring is a weak link, but tension is a universal issue for joystick devices. We have a whole host of other issues to look at today. There have been many iterations of Hall Effect and TMR sticks, some of which absolutely terrible. Issues with anti-stick drift thumbsticks so far have been low resolution sensors, weak recentering springs that lose their tension very quickly and cause sloppy recentering, exploding experimental thumbsticks, algorithmic manipulation which causes a disconnect between physical raw input and digital output, and of course we have the circularity manipulations, that way people can get 0-0 on gamepad tester tests. I'm saying a whole lot right now, but most of you are probably like,
what the fuck are you talking about, man?
I'm going to have to explain certain things as we get through testing because there is a little bit to go through. We have 6 devices for testing today. We have the DualSense and Xbox Series X stock controllers for potentiometers. We have the G7 HE and the Vader 5 Pro for Hall Effect sticks. And for TMR, we have the G7 Pro and the Raiju V3 Pro. But wait, there's more. I'll be throwing in a 7th device for extra metrics, and it is, surprise, surprise, the original Gamester G7. So now we have potentiometer, Hall Effect, and TMR sticks from the same family of controllers to compare over time. Testing will involve resolution, bitrate, tremor, polling rates, response times, inner and outer dead zones. We have X input test or polling 2 for polling rate testing, as well as Prometheus 82 for response time testing. We have the Stick Tracer app for dead zones and bitrate, and the Line app for resolution, linearity, and tremor. The full goddamn suite, all of which is linked below. Everything is wired on PC, and to start we have the things that they're all equally good at. All controllers appear to have little to no inner dead zone, none of them snap from the center, and all of them appear to have a mildly limited outer dead zone by fractions of a millimeter. None of the outer dead zones are perfect. Next up, resolution. Total stick resolution is the number of positions a stick can take between the center and the outer edge, while step resolution is basically the size between each step in resolution. But for our comparisons, we're using total resolution. The average stick resolution is anywhere from 100 to 150, so our stock controllers do just fine here. The G7's potentiometers do a bit better, but some of these TMR sticks are capable of resolutions of up to nearly 2,000. The keyword is some. Clearly the Raiju does not kick nearly as much ass as the G7 Pro. Hall Effect does pretty well though. Our Vader 5 Pro with all stick settings disabled in the software and the bitrate pushed to 12 gets a resolution of 1100. Our other Hall Effect controller, the G7 HE, performs well, but I would say it's very comparable to the stock controllers. Next up is bitrate, even though I kind of did some bitrate stuff a second ago, but the bitrate. Resolution is based on the smallest movement you could possibly make, but bitrate is how precise that movement data is. I think bitrate still kind of confuses me. I think of it as the quality of the resolution data. The important thing in this category is that more is better, and PlayStation controllers use 8-bit sticks, while Xbox uses 11, and everything else here uses 12-bit sticks, while most third-party Pro controllers use 10 to 12-bit sticks, so most anything is going to be better than stock controllers. Now, circularity error has been debated for some time. This is how far the thumbstick deviates from being a perfect circle at the outer edge. Larger error percentages are to be expected. The hardware is not actually designed to create a perfect circle. Circularity tests are more so important for figuring out if your stick is off-center. But as long as everything is symmetrical and not a literal fucking square, you should actually be fine. The controllers here either hit the average circularity error of 10 to 15% or had no circularity error at all because it's been removed by an algorithm. I knew I'd forget to mention something. When given the option for rectangular or circular circularity options, I would always go circular because those straight lines right there don't seem too ideal for a circular movement. This is the G7 Pro, but I also tested the Vader 5 Pro and it looks something like this too. Next up is linearity. Now this seems to be more user dependent, but some controllers do just have more stable thumbsticks than others. The original G7 performs very poor here and feels highly unstable, while the Xbox Series X controller and the Raiju excel. Despite the fact that overall, I would actually say those two controllers feel the most abnormal out of this whole group. The linearity of all the others were within like 1 to 2% of each other, so for the most part, outside of the two outliers, this was a draw. Something that can greatly affect linearity is tremor, a term I believe coined by John Punch in his research. This is the processing that happens between your raw movements and the final output. Basically, is there any algorithm helping to smooth out your movements, and if so, how often? This is a big deal because the Xbox Series X controller has basically none of it. Same with the G7 HE. But our other Hall Effect controller and both TMR controllers go absolutely wild. But the biggest offender by miles was fucking Sony. That's right, the controllers I have been standing by, the controllers pros have been standing by, are doing more shit in the background to assist your aim than any other controller tested here. And I thought the TMR sticks were bad. You fucking PlayStation dickweeds and your additional aim assist. Next up, we have sampling rate, which is a bit different than polling rate, don't get it twisted. It is what I've seen described as the sensor frame rate, aka how many times per second the sensor is checking for changes. Unfortunately, I have no real way to measure this, although I wanted to mention it because there's a chance I'll be able to measure it sometime in the future for controllers, and I would like to put that data in a pinned comment if I'm able to. So just keep that in mind. But polling rates, we're moving to polling rates. Polling rate is how many times the host device requests data from the peripheral. Now, generally speaking, higher numbers should be better for both, but higher polling rates do drain the shit out of batteries and put a lot of strain on devices. Poll testing went smoothly. Poll testing. That sounded terrible. Polling rate testing went smoothly. Everything reaches 1000 Hertz, aside from the Xbox Series X controller at 125 Hertz. The DualSense obviously reaches 8000 Hertz, and the Raiju V3 Pro reaches 2000 Hertz. And for the billionth time, polling rate does not correlate to response time, but a higher polling rate often assists in having a better response time, which we're going to test now. Now, keep in mind that response time could actually be affected by things outside of the sticks, and it's more so a case-by-case basis, so it's not really for direct comparison. But you guys would hang me out to dry if I didn't at least include that, so I do have to mention the G7 Pro's TMR sticks are the fastest by far, followed by the Hall Effect sticks and the Vader 5 Pro. Then the original G7, following that is the DualSense, the Raiju V3 Pro, the Xbox Series X controller at a snail's pace, even wired, and in last place is a Hall Effect controller?
What are you talking about?
So Hall Effect has the second fastest and the slowest thumbstick, and TMR has the fastest, and the potentiometers didn't even seem all that bad. What's going on? Well, again, this is just more evidence that response times are completely random. Wireless response times are always worse for thumbsticks than they are for buttons, so testing sticks versus buttons is usually a comparison that you can make, but there are now controllers like the Vader 5 Pro and the GameSir G7 Pro 8K, which wirelessly has the same response time or a similar response time for its buttons and its sticks. Same with the Vader here. None of this shit makes sense, and if you would like to check the discrepancy between wired and wireless thumbsticks and buttons or anything in between, you could check it out for your controller on Gamepadla. Most likely. But now we have to put it all together, the mechanical structure, the problems, the solutions, the testing, and all of it, and to find out, once and for all, are Hall Effect and TMR sticks really worth a fuck? The core of the design behind Hall Effect and TMR sticks, magnet bitch, is in fact one solution to one type of stick drift, the major source of stick drift. Capacitive sticks are another solution. All of them remove the contact that wears down the sensor. But all of them also do have their shortcomings, and all of them are restricted by the materials they're made out of, which can stretch over time and cause recentering. The same thing happens with springs, which are an essential component in these thumbsticks. Then there are firmware issues and bad updates that occasionally happen with some of these third-party controllers. As Jeremy Clarkson once said, there are many things that could go wrong here, and in fact have. But when done right, the debate about Hall Effect and TMR versus potentiometers isn't even a fucking battle. Especially nowadays, in most cases, they're going to have higher resolutions, higher bit rates, they'll have high rates of tremor, both Hall Effect and TMR most likely, especially nowadays, which will still be half the fucking rate of the DualSense controller. And again, from what we've seen recently, response times have been getting absolutely outrageous. With capacitive sticks solving the magnetization issues that TMR and Hall Effect sticks have, I think thumbsticks are heading in the right direction 100%. We just need to go there fucking faster. This controller should have ratcheting for its adjustable tension thumbsticks. The cheaper version of this controller on Xbox does, but this one doesn't. Why? Because this controller came out first, even though people have been suggesting this feature for like 3 years. That's just to say that if we learned our lessons faster, we would have amazing controllers very quickly. Now, before I go, I'll hand out some recommendations, because I know you guys need them. Before I do that, though, preface it with this. This is my recommendations from my current collection of controllers. I don't currently own all of the good budget pro controllers, or even the good expensive pro controllers on the market. There are definitely other good devices out there I haven't tried yet, and I do plan to in the future, but I'm just telling you based off of what I have right now. For PC, it's basically open season. You can buy whatever you want, but the Vader 5S has those nice adjustable tension Hall Effect sticks, even though it is a wired controller, and the G7 Pro is a wireless controller that doesn't have adjustable tension Hall Effect sticks, but has, I gotta be honest, some of the best sticks I've ever felt in my life. And the other plethora of features available with it and the Vader 5S are amazing. That whole lineup is the exact same for Xbox, by the way, because there are Xbox wireless compatible G7 Pro models. So you can have a wired or wireless experience there, or you could have the wired experience on Xbox with the Vader 5S. So those would really be my recommendations for PC right now. If you're really going hard with the wireless, then maybe you want to get something like the G7 Pro 8K. For PlayStationers, for gay stationers, you are fucked. There is one pro controller on the market for you guys. I have it. I have not reviewed it yet. I plan to, and you cannot buy it because it is so indescribably fucking slow on PlayStation that it's not worth using over a stock DualSense. I will get fried by anyone in any game using that Raiju controller. Do not buy it for PlayStation. It's only good on PC. If you're on PlayStation, you need to buy a custom controller or a DualSense Edge. That's really your only option. I also have a Redux review coming out in the DualSense Edge since the landscape has changed quite a bit for that, but it is currently, in my opinion, the best PlayStation Pro controller to buy. And it hurts to say that because it's expensive and doesn't have a lot of features, but it's way cheaper than custom controllers. And for Switch people, the Cyclone 2. I'm just going to say the Cyclone 2 because I love the Cyclone 2, even though I haven't used the Cyclone 2 much on Switch, mostly because I don't own a Switch, because I fucking hate Nintendo. I don't want to do that. I didn't mean to, oh shit. Ooh. The recommendation portion of this video, I do have to admit, is a bit sloppy because I have been away for some time and I'm just now starting to get controllers sent in from companies, and I'm starting to buy controllers. I have the Rainbow Pro 3 in the, well, not in the mail, but it's going to be on the way soon. So recommendations as time goes on will probably get better, and I may update a pinned comment featuring that information as well as things like sampling rates once I get them. But I hope that has answered many of your questions about Hall Effect and TMR sticks so far. I know I didn't cover everything and I wasn't as detailed as I could have been with some topics, but I wanted to get a general covering of a lot of different stuff and go into details about specific things that I thought were important. If I missed anything, again, be sure to let me know in the comments. UMG claimed my outro, so what am I going to do for my outro? I got a Zenless Gamester G7 sent over. Everyone else who's made a review is completely fucked, because I'm going to steal all the legacy views for this thing. Got a perfect title and thumbnail for that. You guys will be, and I can see now that I'm uploading more consistently, I can just do that. Love you guys. Gotta go edit this. Sweating like a pig right now, even though it's winter. Oh my God.